Hello students, we will begin to study the mechanical properties of materials. Mechanical properties of materials are also embodied in four aspects. The first is its strength, the second is its elasticity and plasticity. In fact, this is a kind of deformation ability. The third is its toughness and brightness. The fourth is its hardness and wear resistance. First of all, let's look at the strength. It is easy to understand. That is, the material under the action of the load to resist plastic deformation or the ability to destroy. Let's start with strength, right? Well, strength is the ability of a material to resist plastic deformation or destruction under load. The deformation of material is generally composed of internal deformation and external deformation. A material's ability to absorb energy by changing its shape under the action of an external force is referred to as its elastic and plastic deformation. Material failure, on the other hand, occurs when external forces exceed the material's load-bearing limit, resulting in structural changes that render the material non-functional. Another aspect of the material strength is known as specific strength, which is a strength indicator calculated per unit volume of material mass. Its value is equal to the material strength divided by its apparent density. The table below presents specific strength, and apparent density for materials like low-carbon steel, aluminum alloy, ordinary concrete, and more. The chart demonstrates the mechanical properties of various materials based on their strength and density. Next, we move on to elasticity and plasticity. Elasticity is a concept we encounter frequently in our daily lives. It refers to a material's deformation under external forces, which, upon removal of the forces, fully returns its original shape. For instance, when we compress a spring, it can return to its initial state. Plasticity, on the other hand, describes material's deformation under external forces, where some of the deformation remains irreversible after the forces are removed. An everyday example of plasticity is modeling clay. Moving on to the third aspect, material toughness and brittleness. Brittleness occurs when a material subjected to external forces suddenly fractures without any noticeable plastic deformation when external forces reach a certain value. For instance, think of glass shattering upon impact. Toughness, on the other hand, refers to the material's capacity to absorb substantial energy and undergo significant deformation without breaking when exposed to impact or vibrational loads. An example of material toughness is the rubber spots used in our bridges. In the fourth aspect, we delve into the hardness and wear resistance of materials. Hardness refers to a material's surface resistance to indentation or abrasion and serves as a performance indicator for measuring the material's degree of hardness or softness. Common methods for testing hardness include scratch testing, indentating testing, and rebound testing. Wear resistance, on the other hand, denotes a material's ability to resist wear on its surface. The wear resistance of material is closely related to its composition, structure, strength, and hardness. The chart below illustrates the variation in hardness for metal materials. With this, we conclude this section of the lesson. Thank you, everyone.